So in 10.2, we're talking about distance formula, and basically how do we find the distance between 2 points. Now, in real world, if I was in construction, let's say, and they said, what's the difference between these 2 points? I'd just take my tape measure and I'd just directly measure from point to point. That's not an option, though, when we're on a grid where we only can measure left and right and up and down and cannot directly measure diagonals. So, if we have a grid, now we can easily count the change in y. Right, so there's my change in y, which is 1, 2, 3, 4. Now with distance, we only talk about positive values. Only positive. So even though, depending, right, this one is actually a positive slope anyway, so we wouldn't have an issue in this case, but if it was a downward slope, we'd still only talk about positive measures. So for my x, it changes by 3. So I've drawn this right triangle, meaning 90 degrees. And now I have all of the legs, and I just need the hypotenuse. So Pythagorean theorem, a squared plus b squared equals c squared, which, by the way, only works with a right triangle. If my a is, we call that 3 units, so 3 squared, and then my b was 4 units, so 4 squared. So if I add the sum, right, if I get the sum of the 2 legs, that will equal that hypotenuse squared. So 3 squared is 9, 4 squared is 16. And remember, order of operations, we do the parentheses, then the exponents, which is why I do 3 squared first as opposed to trying to somehow add 3 plus 4. Can't do that. You've got to square them, then add. So 9 plus 16 is 25, is c squared. And from here, if I square root both sides, if I take the square root of something is equal to the root on the other side, so 25 squared equals, or root 25 equals the square root of c squared. And whenever you square root something that's squared, you're left with just that value. On the other side, we have 5. Oop, wrong button. 5. So 3, 4, 5 triangle is actually one of the common triangles we will talk about as far as right triangles go. So that's basically how we're finding the square. We just are taking this and moving it. So now, instead of taking the graph and turning it into a triangle, and then taking that triangle and finding its the length of its hypotenuse, we can plug everything all in at once, so there's just one giant step. Right. So a, negative 3, 5. So negative 3, 5. B, it's 2 comma negative 2. So step 1, graph the points. Check. Step 2, create a right triangle with a new vertex at point C. Right, and vertex is again just where two lines meet. So if we're writing a triangle, let's go make a straight line shape. Okay. Straight down, straight across. So there is my C, which I just did 2 and 3 kind of same time. All right, what is the distance from A to C? let's actually go back and label. A was this one. And then C, by the way, is -3, comma, -2. All right, so that's the point. So the distance from A to C, graphically, I can just go and count, right? 1, 2, 3, 4, 5, 6, 7. Or using the numbers, so from A to C, it's the y value that's changing. So I go from 5 to -2. Which is part of the B as well. So from 5 to -2, you do 5. The difference, when you're finding the difference between 2 points, you subtract. So 5 minus -2, which becomes 5 plus 2, which is 7. Let's move that over a bit. Make it a little prettier. 5 plus 2, which is 7. And then the distance from B to C, which is from this one, B, and then this is the C value. 2 minus -3, which is 2 plus 3, which is 5. So now let's count. 1, 2, 3, 4, 5. So what we just illustrated is this concept, which it looks scary, but if you break it down into really what it's saying, it's not so bad. So if A is my x1, comma y1, and then B is x2, comma y2, x2 and y2, then x1 and y1. So since distance is a difference, you subtract them, and you just have to be very careful with the negative signs. When everything's positive, it's not so bad, but if one of the values is negative, you have to be careful whether or not you're subtracting the negative or have a negative value and then subtracting more from it. So we've just said that if A is x2 minus x1, then we can substitute. A becomes absolute value x2 minus x1. And the reason we're doing absolute value is because, remember how we said we only count the distance as positive? Well, if you end up with x2 minus x1 being a negative value, we want to ignore the negative part, absolute value. So we take that whole thing and then we square it, and then B becomes absolute value y2 minus y1, square that whole thing, which is then equal to c squared. So if this formula right here, if this part is too much for you, just remember it comes from a squared plus b squared is c squared. Just calculate a and calculate b separately, then plug it in. Once we have this far, that last step is, remember before we had root well, no, we didn't have the root yet. We had 25 equals c squared, and then we went back in and square rooted both sides. That's all we need to do, only instead of this 25 simplified version, we've got this entire pre-simplified version. So then you've got the square root, all that stuff inside equals c. So that whole piece becomes c. So here's the distance formula. So instead of calling it c for the hypotenuse, we're just using a capital D to stand for distance. Everything else is the same. So let's actually pause here, and then we'll do the second part, which is what to do when your square root isn't simplified, in a moment. If I can figure out how to unpause it.